Hello students, today's topic is memory management technique. This is the second lecture of operating system unit for memory management. So let us see the different types of memory management technique. The first one that we are going to learn is known as contiguous memory allocation. So as we know, like in the previous class or in the previous lecture, I have mentioned that whenever the process is ready to get executed, the process is copied to RAM from the secondary storage. Now when the process gets copied to the RAM, there are different memory allocation methods, and the first method that we are going to study today is known as contiguous memory allocation. So the name itself tells us that a continuous block of memory is allocated to the process whenever the process is copied to RAM. So let us see what happens in this type of memory allocation. So if you see the entire process is very important. It's not the part of the process, but the whole process is copied to our RAM and it gets a single block of memory, and this single block of memory is a continuous block. So for example, suppose if we copy the process, so it gets a single continuous block of memory. This kind of memory allocation actually sometimes may be prone to external fragmentation. Okay, and how it is implemented, how this contiguous memory is implemented? This is implemented by using the fixed partitioning, also known as static. So what is this fixed partitioning? It simply means that the memory or our RAM is divided into fixed sized blocks. Okay, so here is an example. If you see, this is an example of our RAM. Here is 15 KB of memory, and if you see this 15 KB of memory, it is divided into 1, 2, 3, 4 and 5 blocks. Okay, if you see the first block is 5 KB, the second block is of size 2 KB, the third block is of size 3 KB, the next is 3 KB, and the last block of the memory is of size 2 KB. Okay, so if the process comes, suppose the process, now like how do you know like the first blocks are only allocated, or why not these blocks are allocated? Who decides, or how it is decided that which blocks of memory will be allocated? So the block of memory or the partitions are allocated as the processes arrive to the RAM, and there are some algorithms to decide which block of memory will be allocated to which processes. Okay, so we are going to see these algorithms afterwards in our lecture series. Let us see the advantages of a fixed size partition. This is very simple and easy to implement. Of course, it supports the multi-programming. Now, what do you mean by multi-programming? Multi-programming means, so it simply means that it is possible to copy more than one program or more than one process in our RAM. How many processes are present in the RAM is known as degree of multi-programming. Okay, so let's come back to the advantage. So this fixed size partition scheme supports multi-programming. Okay, why? Because multiple processes can be stored inside the main memory into the different partitions or into the different blocks. Okay, management is very easy using this scheme. Let us see the disadvantages of fixed size partition scheme. The first disadvantage is there is a possibility of internal fragmentation, there is a possibility of external fragmentation, then there is a limitation on size of the process. In the previous example, if you see, in the previous example, I said like suppose the process is of size 7 KB, we can allocate these two blocks. But what if the process is of size 16 KB or 17 KB? Then we cannot actually load that process. Okay, so that simply means that there is a limitation on the size of the process. The last disadvantage that we are going to discuss is degree of multi-programming is less. Since we have the fixed size partition, so we can actually totally depends upon the size, totally depends upon the number of partitions, how many processes can be copied into the RAM, and how many process decides the degree of multiprogramming. The next type of division of memory is known as variable partitioning, also known as dynamic partitioning, because this partitioning is done, or the processes are allocated the partitions during the execution. Okay, so that's why it is known as dynamic. How RAM is divided? What is the size of each block? So it totally depends on the process size. As the process comes, depending on the process size, that much memory is allocated to that particular process. So if you see this particular diagram, in this diagram, this is a RAM. There is some memory. So there is some memory fixed allocated for our operating system. And suppose the process P1 or the process 1 comes to the RAM, then if the size of process P1 is 3 MB, the partition size also is equal to 3 MB. So the first partition is made for the process P1 whose size is 3 MB. Then next process comes. Process P2 comes. What is the size of process P2? The size is 5 MB. Okay. So the second partition is of size 5 MB because that is the size of our process. Then suppose there is one more process, third process P3, and whose size is 8 MB. So the third partition is of size 8 MB. So if you see here, as per the processes, as and when the processes come, depending on the size of the process, memory is divided accordingly. So there is no fixed size. Okay, there is no fixed size. Depending upon the size of the processes, at different times, different sizes of the memory will be allocated to the process. So if I ask you what is the size of the partition, size of the partition is exactly equal to the size of the process. Let us see some advantages of variable size partition scheme. The first advantage is no internal fragmentation. I mean, it is zero internal fragmentation. The second advantage is degree of multiprogramming is dynamic. If we have bigger processes, the degree is less. If we have the processes of smaller size, then the degree of multiprogramming is more. Okay. Then it's also the third advantage is there is no limitation on the size of processes. It doesn't matter whether your process is big or small. Okay. Let us see the disadvantages of variable size partitioning scheme. The first disadvantage is external fragmentation. There will be external fragmentation. And the second disadvantage is it is difficult to implement, not like our static or fixed size partition. That is simple to implement, and this one is difficult to implement. So that's all for today's class. In the next class, we are going to learn what is paging. Thank you.